Live streaming is on.
Hello and welcome to the WiMLDS Hyderabad's 10th online meetup, everybody, and thanks a lot for being here. As we all know, WiMLDS Hyderabad is the official chapter of the Women in Machine Learning and Data Science from Hyderabad, India. And this time we're actually very happy to have two amazing speakers with us, Su and Melissa Fabros. They're from Delta Analytics. And if you want to know more about that, you'll have to wait only a few minutes because they'll be talking all about Delta Analytics, and they'll also be telling about their Teaching Fellows program, and along with that, their individual backgrounds. So I'll just quickly introduce both our speakers, and from there, they'll take on forward from there. So Amanda is the co-director of Delta Analytics Teachings Fellows Program, and she is currently a health policy PhD student at Stanford University, where she specializes in health economics. Melissa is the teaching lead at Delta Analytics Teaching Fellows Program, and she's a machine learning and full stack engineer for Kiva.org. So welcome, Amanda and Melissa, and thanks a lot for being here today with us. You can take on from here.
Okay, thank you, Pearl, for introducing us. We're really excited to speak to everyone at the Hyderabad chapter for WiMLDS. Today, we wanted to sort of spend a bit of time talking about who we are as an organization for Delta Analytics and sort of go into some of our teaching fellows initiatives over the years, and also give a bit of background about who we are as people and sort of our own paths towards machine learning and data science. So let me start off by sharing a screen. Great, can everyone see my screen? Okay, I'm going to take silence as hopefully consent to proceed. So kind of as I mentioned, we're going to go over a few different topics today, starting with a brief discussion of what Delta Analytics is and what we do, and our mission, a little bit about our Teaching Fellows program, and a short discussion about our own individual paths. I think we'll think about closing in terms of reflecting all the information we present and relate it to sort of building skills and community in the broader machine learning world. So who we are, Delta Analytics. Delta Analytics is a 501c3 nonprofit based in the San Francisco Bay Area in California, United States. We are completely volunteer run, meaning that we are a group of data professionals who volunteer their time working on projects related to data for good. More concretely, our mission is to increase access and usefulness of data to empower changemakers working to better their communities. And we'll come back to this idea of increasing access and usefulness of data throughout today's talk. But effectively, we do this through our two core programs. The first is our Data Service Grant, otherwise known as our Data Fellows program, where we pair volunteer data professionals or data fellows who work on analytics or machine learning projects with nonprofits who have specific questions in mind, and they work on this together over a 6-month engagement every year. On the other side, we have our Machine Learning for Good program, otherwise known as our Teaching Fellows program, where our goal is to empower anyone, anywhere to leverage data for good in their communities by building technical capacity around the world. We've done this by sort of thinking about how we can build technical capacity and sort of developing our own introduction to machine learning curriculum that has accessible content. As an organization since 2013, we've completed over 50 projects with nonprofits and social impact organizations on the Data Services Grant and Data Fellows side. And on the Machine Learning for Good or Teaching Fellows side, we've built our curriculum, we've open sourced it, and we've taught machine learning curriculum to students all over the world. Both of these endeavors have been done with the efforts of over 200 data professionals who volunteer their time to work on their projects. What this means is that we've been able to donate over 20,000 hours since 2013, and we were able to charge $0 for all of our services to sort of make increase access to the usefulness and the accessibility of data and to empower people to use it. So I wanted to spend a little bit of time kind of going deeper into one of our programs, the Teaching Fellows program, since this is the part of the organization that both Melissa and I belong to. So as I mentioned earlier, since 2013, Delta Analytics has been working to help nonprofits around the world with their data. In 2017 specifically, we started the Teachings Fellow program. And when we were thinking about why we wanted to even take on this endeavor, it really came down to 3 motivating principles. The first is that we believe that Delta should never be the bottleneck in any engagement. So every year, we are only able to accept a few of the nonprofits who apply for our data service grant, even though there are like way more salient or the interesting problems that deserve to be addressed. We think about this in terms of what this principle we talked about earlier, building technical capacity, because we also don't believe, so this is related to the second principle, we don't believe that, while technical skills are currently geographically concentrated, we don't believe that they should be. There's talent all over the world, and we believe in sort of investing in building that talent around the world. And this relates to this third principle. The reason we care about building local capacity is because we believe that participation in the machine learning community should reflect the world we serve. It is important to bring on diverse perspectives on any problem in machine learning because, frankly, all of them affect society in some way. At the end of the day, all of this really relates to Delta's broader mission of increasing access and usefulness of data to empower changemakers. We want nonprofits and communities to be able to own their data and to be a part of this conversation about their data. All this sort of drives what we have done. And it also helps us focus on how we wanted to deliver an introduction to machine learning curriculum. So our curriculum very specifically was developed with the goal of being accessible. And when we say accessible, I think this is on a few different dimensions. I personally find a lot of machine learning education to be really daunting with a lot of new terminology, a lot of math that is just thrown right at you. But as an introduction curriculum, we wanted to be able to sort of sit down with you and sort of go through problems each by their own. So here is a slide, for example, from our decision trees module. All of our curriculum, by the way, is available for free on our website and on our GitHub, Delta Analytics, for anyone to sort of view through. But we wanted to sort of be able to work through problems with students, working through exactly what's happening through each step of the way. We also do this by creating Python coding labs and making them also accessible. So here's an example again from our decision tree module, where we walk through exactly what is the decision tree, how do we build it in a notebook format. So students and any potentially interested parties can just download them and work through the notebooks on their own time, working with the functions that we already have here, for example, train score regressor, and seeing if you wanted to change aspects of the function, what would happen. So with that said, I want to kind of turn it over to Melissa, who will go over and talking about some of the key initiatives that we worked on over the years.
Muted. Thanks, Amanda. I've been involved with Delta Analytics teaching fellows since the beginning, since 2017. And in 2017, we built out the curriculum from scratch and piloted the program in Nairobi, Kenya. Slide. Amanda, slide, thanks. And then in 2018, we beta tested the curriculum and revised it and then open sourced it after the pilot. And then we were able to teach the curriculum live in SF Bay Area at various nonprofits, as well as teach it to university students in Morocco. Slide. Next slide, Amanda. Thank you. Last year, we really kind of dug deep to think about how to make the curriculum even more accessible with active learning techniques, and really think about how to deliver curriculum without Delta being the bottleneck. Teaching in Morocco was amazing, but it was a big commitment of time that not all the fellows can take. So this year, next slide, Amanda. We are going global, and we've opened up our fellows program to passionate machine learning practitioners and educators around the world. So we're really excited to kind of bring new talent to Delta, deepen our own bench, put eyes on problems that we might not be aware of, and to expand our reach. So we're really excited about the program right now. And next slide, please. And here are our 2020 Global Teaching Fellows. And we invite you to join their machine learning graduation lectures. Each fellow has been with us for about 4 months now, and kind of learning best practices in teaching, kind of understanding what active and empathetic teaching is, and bringing their own passion for machine learning to those skills. And all these talks will be streamed with Delta Analytics YouTube channel. And we have the schedule, thanks Amanda, starting in about 2 weeks. We'll start celebrating our fellows' success in mastering and presenting the machine learning topic of their choice. If you want more information about how to tune in to these talks, you can follow the Twitter account, Delta Analytics, and all the dates and all the times of the lectures will be at Pacific time. Next slide, please.
Thanks, Melissa, for kind of going through the Teaching Fellows program. So we sort of introduced at an organization level why we care about widening access to machine learning education and why we went through this whole process of creating our own curriculum and teach it around the world. But I think it's also important to sort of address this at a personal level, since Melissa and I are two of the members on the core Delta Analytics Teaching Fellows team. As Parul sort of introduced us, I am the co-director of the program, and Melissa is the teaching lead. And we also, I think, have very specific paths into machine learning and data science that are not necessarily very typical. So I think it's important to sort of think about the people who are coming into this community and how we can sort of broaden access and participation in this form of science. So I'll start off by talking a little bit about my path, and Melissa will talk about hers. When I was an undergraduate at the University of California, Berkeley, I wanted to study economics very specifically because I was interested in sort of thinking about economic welfare and societal implications, particularly of policies and programs on sort of people and populations. So when I was a student, I had been involved in a few different empirical research projects. So working with data, but thinking about hypotheses and questions within an economic framework. I really enjoyed this experience. So I had a very linear next step towards my first job. My first job outside of, after I graduated, was at an economic consulting firm called Analysis Group, where I worked on economic problems and market power studies and experimental research. So bringing in the sort of foundational theoretical framework. Is there? Okay, sorry, I think I had heard some feedback. But when I was at my first job, I was really focused on applying these sort of information I had, theories and applications that I'd learned in school, into very specific problems. It was actually around this time where working on really solidly economics problem, where I was also being introduced in my own casework to different data tools and methods for analyzing problems. I found this really fascinating. It was very different than what I had learned in school, but it was still foundationally concerned with the problems I had cared about in industrial organization and applied microeconomics. Around this time, when I was being introduced to all of these different tools, two things were happening. First, I was beginning to recognize that the sort of access to this type of education, this very specialized information about data and methods, is often pretty narrowly designed. So I think when I think about kind of being introduced to a lot of these concepts, a lot of it is presented in fairly intimidating formats, using a lot of math and a lot of coding and a lot of jargon. And I had met with a group of Delta Analytics volunteers who were also generally interested in this broader idea of widening access to machine learning education. And that's how I got involved with the Teaching Fellows program when it started in 2017. It was also around this time where I recognized that I wanted to sort of challenge what I knew and build upon what I've been learning at Analysis Group in a different domain. Very specifically, I wanted to work in healthcare. So I started working at a company called Nuna Health, a health technology company based in the San Francisco Bay Area, working first in healthcare data analytics. And as a data analyst at Nuna, I worked on studying population health and conducting studies of population health, as well as working on program evaluations. So this a little bit was similar to the general type of work I was working on Analysis Group, and now becoming focused on healthcare. I think really interestingly, something that had happened during this was I was also working on a few data science projects at Nuna, where I was able to leverage this sort of very specialized healthcare domain expertise, working with healthcare data specifically, and able to contribute in this new way. And sort of because of my contributions to data science at Nuna, I was able to transfer to the data science team, where I began working on problems involving matching, or I started working on improving ways that how we match physicians to patients in our matching algorithms. So this is a more foundational type of data science role where we're working with machine learning models to sort of improve our algorithm and sort of developing them and productionizing them. And then here is where I take another kind of weird nonlinear leap. I became really interested in healthcare and thinking about certain implications of certain policy designs on outcomes. So this is really a question that's foundationally tied to my original training in economics. I am currently pursuing my PhD in health policy, health economics at Stanford University, where I'm hoping to sort of bring in all of the methods that I've been exposed to over the past years in economics, in data science, in machine learning into my research. We'll go into a little bit more about what those applications mean, but I kind of as a journey, I actually find this quite interesting. I present it as a somewhat linear looking path, but in reality, the only linear step here is this first one when I went from undergrad to Analysis Group. Breaking in, or as we'll introduce, building into tech and into data science was certainly not something that I had anticipated doing, but I think was really just an accumulation of me learning about different opportunities, different ways of thinking about a specific problem, the same problem really, and using different tools, pushing the limit of sort of what's possible. I think right now I'm really interested in bringing all of these different tools and methods that I've been introduced to the very specific problems that I care about. So this is sort of my path. I'll pause here and turn it over to Melissa to talk about hers.
Thanks, Amanda. Can you tell me if the mic is on, Amanda?
It is.
Okay, thank you. So similar to Amanda, my path doesn't look as linear. It looks like I started out at the same place as Amanda, at the University of California, Berkeley. I studied literature at a PhD program. And then from there, I actually taught at the University of California, Merced. And so right now I'm a software engineer on the data science team at kiva.org. So, well, how did I get there? Next slide, please. It looks a little bit more like a path if we draw this spiral out over it. After the University of California, Merced, I wanted to kind of deepen my exploration of programming and software engineering. I had done it as a child, actually, in middle school. I was the founding member of the computer science club, but opportunities after that just didn't come. So whatever I picked up was very anecdotal, hobbyist in the web development world. And then I decided I wanted to take the leap and deepen my knowledge there. After Hackbright, one of the instructors at Hackbright, Rachel Thomas, had founded a new educational initiative called Fast AI. And so as an educator, it really kind of spoke to me. What really spoke to me at Fast AI was their top-down learning, where you kind of have fun with projects, be excited about that, and then you're able to deepen your knowledge later. Then after Fast AI, I started with Kiva, but at the same time, I actually had started at University of San Francisco. So I took some intro classes at University of San Francisco. Fast AI's approach to machine learning is deep learning, mostly. And then when you find out the problems that you encounter at work aren't deep learning problems, I felt the need to kind of backfill my knowledge a little bit. So I was TAing at the University of San Francisco. I leveraged what I had learned at Hackbright and my teaching skills, and was a TA in their data science program in the Introduction to Machine Learning paths to help students kind of ramp up, especially with their Python. And then currently, there wasn't a machine learning position at Kiva when I started, but now there's a full data science team. So looking at this kind of model, as Amanda mentioned, like, it doesn't look linear, but then there's definitely a path of growth. Can I have the next slide, please? And so if you think of this kind of growing out instead of growing up, you can see this concentric circles is the model of learning from Vygotsky's zone of proximal development. And so usually this is applied to childhood development, but as an adult learner, it applies to how to grow one's talents and skills as you kind of grow your community. So the middle circle is the things that you already know how to do by yourself, your core competencies. The zone of proximal development is generally where you're learning things. You can do things a little bit with help. And then the outer yellow zone is what you can't do or where you feel anxiety. So in growing out of those circles, the zone of proximal development usually means that you have people around you who are either a little bit above you, a little bit behind you when you're learning, but you're surrounding yourself with people on a learning journey. And from being in the zone of proximal development, you learn from others, and you can take your skills to consolidate them to teach others who are just starting to stretch out of their comfort zone. So can I have the next slide, please? So the idea from the zone of proximal development, so we see the spiral again, and the kind of major points of development is like working from your strengths. So what I did was leverage my teaching, communication, and collaboration skills to learn technical skills, reinforce those skills by teaching them to others who are just trying to emerge from their comfort zone and learn something new. Learning something new is one of the scariest things because you're purposely putting yourself out there for things that you know that you can't do. But in that zone of proximal development, you build your community of friends and colleagues in that growing phase. So this concept of zone of proximal development is that you surround yourself with a community that will find ways and opportunities to help you to get where they are, or you help other people to grow their skills. Can I have the next slide, please? And so the idea that I think one of our questions that Parul gave us to think about was, well, how do you break into data science? People have invested a lot of time and a lot of money, perhaps, if you've taken a paid program, to build these new skills. And what do you do with them afterwards? And so if we think about the zone of proximal development, building collaborations is key. And materially, they can be really successful in growing everybody's goals. So Delta Analytics, when I got involved, was just beginning its teaching program in Nairobi. They were struggling to find a robust and flexible data set that would apply to many different places. But when I got involved, I had also just started at Kiva, and I was working on documenting their data snapshot. So I happened to know that there was an open sourced, robust international data set that spanned over 10 years. So while Delta Analytics had the one piece about like, well, we have this goal and vision to create machine learning curriculum, but we don't have a good foundational text, a good foundational data set. And I'm like, oh, wait, you should try the Kiva data set. And so working together with Delta Analytics has been a fruitful partnership over these years of starting with that one collaboration, now serving an international audience. And then in your own position, you can be the agent of organizational change. So when I was brought on to Kiva, I wasn't brought on to a machine learning role. I had come from a programming boot camp. I had learned full stack engineering. I had done 2 technical internships, and then, and I had this extra additional competency, new competency in machine learning. So what I was able to do at Kiva was start connecting Kiva with the resources and perspectives that would help it create organizational change to adopt machine learning. So I've been at Kiva for about 3 years now, and from being kind of a small R&D experiments practice, we now have a full data science team with 2 senior engineers. A data engineer is coming. We're interviewing for a data engineer right now, and then myself working on data pipelines and modeling and exploratory data analysis. So you don't necessarily have to break into an organization. You can be the agent of change in your own current organization, which Amanda can also speak to.
Yeah. So in this last point, we are also going to think about being your own agent of change, specifically finding if you work in a very specific domain, like healthcare, like agriculture, or any sort of topical area, I think it's really valuable when you're able to identify when are good opportunities to use methods that make sense. The example here is not good because it's about me, but I work interdisciplinarily, and this means applying data science concepts to my research ideas. This is very abstract as a statement, and I think it's also interesting because when people think of health policy, you think of it as a qualitative research field, when in reality, there is a lot of quantitative and empirical, meaning data-based research projects that are out there. And what this lens is, particularly in areas like economics, means that you can borrow these methods from machine learning and apply it to areas that we care about. So in economic research, there's a strong emphasis about thinking about causal inference and being able to identify specifically and measure the effect of some event on some outcome. There's a body of research in economics right now that focuses on machine learning for causal inference, methods such as causal forests. And in health policy specifically, there can be methods of using machine learning to improve healthcare methodologies like attribution, like risk adjustment, which are just jargon at this point for this audience. But at the end of the day, what it means is these are healthcare methodologies that are applied to determine, for example, how much physicians can get paid. So it has incredibly important policy implications in sort of determining payments, making sure that patients can access healthcare, and thinking about system-wide what healthcare can look like. So we kind of introduced these ideas of sort of breaking into, or what we think of it as building upon your skill set and sort of growing into data science. And I think this is really important to be paired with this idea of building community. So here's a slide that sort of has three different pillars. One is learning, one is contributions, and the second is sort of thinking about community. I think when we think about building skills, we've all taken probably some sort of classes. I think what is particularly salient is when you can be, if you're in an online class, you're a part of one that have supportive communities that can help you grow. So it's not just focused on doing the coursework or whatever exams and milestones, but also sort of thinking more critically about a problem. We pitch our own sort of curriculum that hopefully sort of engages students. And I think it's also very salient, if possible, to sort of form peer study groups where you can sort of bounce ideas off of each other, work through problems, find out new ways of thinking about the same problem. And it's sort of this interactive component that really fosters at least my own growth. The second sort of pillar is focused on this idea of contributions. Everyone comes in with some interesting background, and it's really important to be able to recognize that you're coming in with these skills that you have already. We believe that it can be useful to contribute your own perspectives on problems that can use machine learning and data science. In more concrete terms, this can fall under at least three different buckets, definitely more. The first is sort of being able to create data sets for machine learning problems you care about. The obvious example is that in natural language processing, there is a dearth of languages that are being studied. There are ways to sort of add your voice to policy problems and methods that you're interested in. So these are similar to the ones that I had mentioned earlier about how health policy is beginning to use data science and machine learning concepts to enrich their own work. The third, if this is a path that makes sense to you, if you're naturally extroverted online or similar, is to sort of think about how you can contribute to the education opportunities that are out there by authoring blog posts for future learners, by creating YouTube channels and doing coding labs online, and similar ideas, or even in terms of your own individual skills and contributing, participating in competitions like Kaggle, where even if you don't rank well, hopefully you'll have still sort of thought about the problems and how you can sort of build upon your experiences there, learning from what you've done. But I think all of this is important to sort of link back to this idea of community, in part because Delta Analytics is really a community focused on data for good, for example. There are ways to sort of bring the skills that you've learned to your own local communities. We don't endorse any of these except for Delta Analytics, but some suggestions Could be organizations like Pi Ladies, Our Ladies, WiMLDS, our audience today, or even perhaps the Delta Analytics Global Teaching Fellows. And I think one really strong takeaway that we wanted everyone to sort of think about and leave with today is that you have skills, you have domain expertise in something. They're yours to sort of think about how you want to apply to problems that you care about. Having a lack of a formal position doesn't invalidate your experiences or your skills so far. I think these are things you've already earned, and it's more of a question of framing, thinking about it in terms of growing out of your comfort zone, putting yourself in positions where you are being challenged mentally, intellectually, and looking for these sort of opportunities that may arise organically. For example, when Melissa got involved with Delta Analytics, that was definitely through an uncommon venue by just knowing that Kiva had this data, that she knows how to work with this data. And that is really powerful, in our opinion. So just with that parting thought, thank you everyone for sort of listening to our talk today. Melissa and I are really grateful for your audience.
Yeah, thank you, Amanda. Thank you, Pearl, for the invitation to share our stories.
Awesome. I mean, it was such a powerful presentation, and I think you people already answered so many questions that a lot of people had sent me regarding getting into data science or switching careers, or even using their domain knowledge into the data science. But there are a few questions which I'd specifically like to ask you. So a lot of people wanted to know if the Teaching Fellows program was in any way open to people outside US, particularly if Indians who are interested to apply for next year. What is the process for that?
I can answer this question. So very currently, the Data Fellows program is not open to actually anyone outside of the San Francisco Bay Area. But with this new environment of COVID-19 and everyone working remotely, this is actually an area that we are considering opening up more broadly. So if you are interested in getting involved, I believe the application cycle could be coming soon. So the best place to find updates on eligibility is the Delta Analytics website, deltaanalytics.org. And typically what happens in this process, I believe, for the Data Fellows, so this is the program where you, as a volunteer data professional or data interested person, would get involved with working with a team of other data professionals or interested people to work for a nonprofit's specific question for 6 months. I believe there's a short open application process and an interview, and then a matching process to the nonprofit of interest. So sorry I don't have better answers for now, but I think the best source is to look at our website, but also feel free to email me directly with questions.
And
Awesome.
also, if
So
you add Delta, sorry,
yeah, sure. No, please.
Following Delta's Twitter is a very good resource, because that's where we make our major announcements around application periods and projects and who we're working with.
Awesome. So I'll be putting the link to the Delta Analytics website as well as their Twitter handle in the description, so that you can go and look at it yourself. So there's another question. So like you mentioned, that there is a open source machine learning course of Delta Analytics. So is that available publicly on GitHub from where the people can access it, like for their own study?
Yes. So our curriculum is available both on our website directly at deltaanalytics.org/curriculum.html, as well as our GitHub. Our GitHub has both the slides and the coding lab, so you're able to access all of that information at once. Our GitHub handle is Delta, DELTA Analytics, ANALYTICS, so 2 A's between Delta and Analytics, which is different from our Twitter, where you are able to go through module by module, topic by topic, focused on each module, where there are both the theoretical concepts as well as coding labs, and I believe also some practice problems where you can work on your own. You're able to download the notebooks to your own local desktop and work through them. All of our coding labs are written with Python 3 in mind.
Some projects with the Delta Analytics curriculum have been, someone has translated the slides into Spanish, someone has translated the slides into Arabic. So again, inviting people to take the material and build their own community around it.
Yes, if you're interested in sort of reviewing or getting involved with the curriculum on that side, I recommend just emailing me and Melissa directly, and we can sort of talk about what collaboration could look like.
Awesome. So there's another question. So Niharika wants to know that coming from a non-programming background, how could somebody become a successful data scientist in a way that she says that every day we see some new things are being added to the learning list. So how should a person who's new to coding but is interested into making career in data science tackle these situations?
Do you want? We actually both come from non-coding backgrounds.
Yeah.
Amanda, do you want to share?
Oh, you can go first.
I came from a non-coding background technically. However, like if you take the skills of learning a new language, a new speaking language, you can apply those skills to learning a new coding language. What needs to be important, kind of foundational for you, that you think that it's fun, that it's because you're going to make the mistakes of someone learning a new language, and you have to kind of be a little bit kind to yourself while you make those mistakes. But the more that you do it, the more fluency that you have, the deeper the patterns that you can see and the nuances. So my particular path was, I tried a couple books. A lot of them were not fun, and were very daunting. There's one that I recommend for people right now that is kind of fun intro. I used Python the hard way, I think, is my first text, but then I also used Code Academy just to understand what the syntax was and how Python speaks back to you. Then after that, I took the dive deeper into Hackbright as a part-time student to make sure that I liked it before going into their full-time program and deepen my knowledge of like, well, how do I do imports? What does a whole architecture look like? And that's where I started. So you have to be motivated. It has to be fun for you in those really, really beginning steps, or a certain kind of motivator. There has to be something in place there for you.
Yeah, I agree with Melissa's points. The only thing I want to add is I also come from a non-programming, I came from a statistical programming background, which is very different in some ways than the kind of programming you'll do in data science. And I think the advice I would like to add just onto Melissa's foundational concerns is that if you are picking up a language, it is good to focus on one. Don't think that you should make the decision early that you're going to learn Python first versus R first versus something else. Working through different languages at the same time is very difficult, and also not a good use of your mental space. So sort of thinking about one. I also think Python the hard way is a good starting point for Python. I think there are also a lot of R resources that are available for free online. What's important to me is reading the text. It always feels like I can do this, but it isn't until, for me at least, when I work through an actual problem with real data when you kind of struggle through that process and sort of persevere through it, where I do a lot of the real learning. So this is salient because I think this relates to this earlier point we had brought up about forming peer study groups whenever possible. I think when you have one solution to a programming or data science like problem, it's really helpful to compare against what other people's approaches are. So you can sort of see what is efficient, what is a good solution, or even appropriate solution, or if there's steps that you may have missed in your own process.
I think the other text I would add to Learn Python the Hard Way, I've started recommending it, is Automate the Boring Stuff with Python. That is also a book that's free online, and it kind of gives you a perspective of like, oh, this is what I used to do, but now I can automate that, and it has the same kind of basic building blocks of fluency into Python.
Great. I think I also started with the two books that you even mentioned, so I also really recommend them. There's a question I think which is pretty prevalent in our meetup groups, and a lot of women they ask me is that a lot of women sometimes they take break, especially maternity, and so sometimes what happens is that maternity break extends into like 2 or 3 years, and then when they want to get back into work life, they really have a hard time finding job, especially in data analytics domain, because what actually happens is when people go in for jobs in data analytics, the companies ask for some experience, and they'll only get experience once they get a job. So this is just a circle. And so this is true for students also who are freshers, who are just starting out their careers, and especially for people with a break. So any points that you would like to share, like how can people get this machine learning or data science experience?
Do you want to take that, Amanda? Do you want me to take that?
I can start, but I think Melissa should finish, as she might be a bit closer in terms of her experience to someone who has freshly started, basically because I have been given opportunities at many steps. I think something that is very valuable when you're coming in without work experience is to be able to demonstrate the skills that you come in with. So very concretely, I think some of this can be accomplished by creating public artifacts of your work if that's something you're comfortable with. So that's either things like participating in pre-established competitions like Kaggle or similar. I don't endorse any of these, but that's one avenue. Another avenue is if there are very specific problems that you are interested in and there's data that exists, is to sort of address them yourself, sort of have a question in mind, a testable hypothesis, go through the entire research process of sort of data analytics and exploratory data analysis, modeling, and sort of thinking through what the implications of your results mean and being able to present that in something like your own GitHub or personal portfolio is one way to sort of be able to demonstrate this skill. I think an important component, in addition to building up and showing your skill set, though, is still, again, on this idea of community and networks. So being involved where, if it makes sense for you, in organizations where you are introduced to opportunities and people who you wouldn't have otherwise expected to meet, who have problems, where you can fill a niche. These are things that happen a bit more organically and can take a bit more of a time investment. So depending on your timeline, those are the sort of two areas that I think I would recommend, but I think Melissa has a very large perspective on this as well.
Thanks, Amanda. Actually, I plus one everything Amanda said. Public artifacts and being able to speak to the details of how to solve a problem are kind of the key. So for myself, I partnered with a friend on a Kaggle competition. And so where I could really speak to was like, well, how do I install TensorFlow in a GPU? Like certain kinds of struggles like that, or how to build a pipeline, how to like read how to look at satellite data. So neither of us had done this before, and we both learned a lot just trying to wrap your head around the problem. If you Kaggle competitions are time bound, but they have sometimes wide swaths of being time bound. And so you can pick up one that's already been finished as a way to grow your skills and kind of check your answers afterwards or check your approaches afterwards. And so this is a very interesting topic for, let's say, women who want to kind of band together. I think machine learning and motherhood is a understudied topic. And so maybe it's going to be like how many words, like how many different words your child is picking up in their developmental cycle, versus like comparing that to like how neural nets are functioning, or how much time something is taking. And if you start to get together with your community of mothers who are taking a break and learning data science, they can together build a very powerful data set that speaks to issues that they care about. It's a very good example of like eyes on a problem that researchers don't necessarily have their eye on, because they don't have the data sets, they don't have the experience, they don't have the interest, but maybe you do, and you and this community that you build together do. So the important foundational thing under that is that you do have someone to support you. It's going to feel, if you're trying to do these projects alone, it'll feel lonely, and like it's never a good time when it's just you and Stack Overflow. But if you have friends to kind of help you explain things, like this is what this doc means, this is what this function does, or explain it to babies, right? So like there's a whole like board book series of like machine learning for babies, quantum computing for babies. So those takes, your perspective is important in kind of expanding the field that way. But if you apply those skills to the problems that you currently care about, and if those problems that you care about are motherhood or child rearing or community building, then the skills underlying that transfer to other types of problems.
Awesome. I think you've answered all the questions, and you've also answered a lot of other questions that we thought we had, and we never saw it from that perspective. So it's been such a great session, and I think we are done with all our questions. I'd just like to thank you, and there are other viewers also who are thanking you because they really enjoyed this entire session, and it's been very informative as well. So again, I'd like to thank you on behalf of our Hyderabad Women in Machine Learning and Data Science team and the community for taking out the time and joining us and telling us so much about the whole about data analytics. But what we really took away is how you two, from a very different background, ventured into data science, and now you're actually pursuing your passion also, and you're helping the community, which essentially should be the whole idea of actually machine learning and data science. So thank you, Melissa. Thank you, Amanda. Thank you again.
Thank you for having us. Great.
Yes, thank you for the invitation.